Alrighty, check, check. Can everyone hear that okay up the back? Yeah. Good? All right, nice. Cool. So hi everybody. Thank you so much for coming down to Brisbane.AI. It's really awesome to see so many people getting involved and supporting the kind of AI community in Brisbane. Also, huge thanks to Nat for running the events. I know a lot of work goes into these behind the scenes. Organising sponsors and finding speakers, and it's really not easy, so thank you. So this is a talk entitled Machine Learning for Startups Without PhDs. It might actually be useful to startups, or for people with PhDs and startups, I'm not really sure. But the point is that it's very much kind of a practical machine learning engineering talk for sort of people with time and monetary constraints. Like those in startups. All right, so who am I and why should you care? Why am I giving this talk? My name's Lex. I am the CTO of Scrunch. So we run a platform that helps brands sort of find and collaborate with these things called influencers, which we'll talk more about soon. I'm not a data scientist. My technical background is kind of mostly in software development and operations. But I have been working on building machine learning products for the last sort of 2 to 3 years at Scrunch. And I thought it might be interesting just to sort of see how companies can go about building machine learning products if maybe they don't have sort of formal training. And also, I guess we've learned a lot of useful lessons about shipping our ML products into production that I thought might be useful to the community. So hopefully that's the case, we'll see. And just a side note, I guess some of the ideas in this talk aren't exclusively ours, like they're kind of out there online. And so where possible, we've sort of tried to include the original source. But we have, for most of the ideas, we've sort of validated them on our own business problems. Cool. All right, so what is this talk about? So there's going to be sort of 4 parts to this talk. We're going to talk about, firstly, what is influencer marketing and how does Scrunch help? Then we're going to talk about how we're using machine learning to sort of solve some of our unique business problems. And then hopefully that'll give you some context for the kind of the main part of this, which is going to be about how we build ML products at Scrunch. And we're going to sort of give some advice for smaller organizations with similar sort of time and monetary constraints looking to do the same. And it'll include some notes about how to get started, even if you have sort of no skills or no data. And then lastly, we're going to look at sort of the future of machine learning research at Scrunch, and we're going to tell you we're hiring. All right, so firstly, what is influencer marketing and how does Scrunch help? Part 1. So to understand what influencer marketing is, we need to first talk about what is an influencer. So basically, an influencer is somebody with an audience. In the context of influencer marketing, we're sort of generally talking about people on social media or people in the, people who have blogs. But of course, influencers could exist outside of social media. I've included a couple of examples of some sort of notable influencers. Marcus Brownlee runs a YouTube channel that's sort of like tech focused, that's really interesting. Cardi B on Instagram has a really good Instagram feed. Brisbane Threads, a blog that was sort of started by our CEO. That's really cool. You should check that out. And Andrew Ng, who's obviously a really influential person in AI and who's a lot of the ideas from this talk are going to come from stuff that he's said. Anyone can be an influencer. That's kind of the cool thing about it, but it takes a lot of work to build a loyal and genuine following. So, what is influencer marketing? So basically, consumers, we've been conditioned to ignore online advertising. When it comes up in your Twitter feed or your Facebook feed or whatever, you just sort of skip right past it and block it out. So influencer marketing basically gives brands access to a sort of, a higher level of engagement. And basically, brands work with influencers to produce content, and they pay for access to this sort of influencers, engaged audience. It allows influencers to kind of monetize their audience that they might have been working on for a long time, and some of them are even making livings off it. And then ideally, consumers are getting kind of product recommendations from people they trust in the ideal world. So influencer marketing at its best, brands are going to basically find influencers who are already advocates for their products or similar products and collaborate with them. So when it's genuine, it's good for everybody. Consumers get useful recommendations from people they trust. Influencers maintain trust with their audience, and brands get a good return on investment. And I've just included sort of 2 examples of campaigns that we've run recently where the influencers were sort of really stoked to be a part of it. One of them is camel milk skincare, where the influencer discovered that it was actually really good for their child's eczema, so they were really happy to be promoting it. And then another one, Cancer Cancel Ugly Xmas Rashies campaign, where a bunch of influencers were able to band together and sort of spread awareness for skin cancer. And then influencer marketing at its worst, it's when it's non-genuine. Audience can usually smell it from a mile off, and it's often not worth it in the long run for the influencers because they lose sort of trust with their audience. And this is kind of the canonical kind of go-to example of bad influence marketing, where somebody's left in the copy there where it says, here you go, at 4 p.m. write the below, and they've posted that on their Instagram feed. I don't actually know if that's real, but might be. Still funny. All right, how does Scrunch help in this process? So we provide influencer recommendations to brands. So we have a search and filtering engine that lets brands kind of like find the ideal influencer for their unique campaign. So they can search across like a range of attributes. We got topic analysis. We kind of try and infer the location of the influencer. We know the location of the audience of the influencer. We know the gender. We know the sort of the audience gender, the age, and many more things. So you can see here, brands can ask questions like, find me influencers located in Queensland who mostly talk about fashion and whose audience is female aged 25 to 34. And really the bulk of our machine learning work is kind of in this. So most of the stuff we're going to talk about is around this, but maybe not all of it. We also provide sort of end-to-end campaign workflows. So we kind of have learnt over the years of doing influencer marketing. We've got some really amazing campaign managers. We've learnt sort of the best practices for how to do influencer marketing. So things like reaching out to influencers, sort of connecting with them, helping the influencers pitch on campaigns, shipping products out to the influencers, managing payments, and all of these sort of best practices are wrapped up into our web application. And then lastly, we do sort of campaign analytics. So after you've run a campaign, we'll sort of tell you how well it went, what the return on investment was, what the engagement was on that campaign compared to other ones, the people that were engaging with it, what their gender is, their age, where they're from, all these sorts of things. Cool, so that's sort of part 1. Part 2 is how we use machine learning at Scrunch. A couple of different ways. The majority of it is in image classification. So we have this massive set of blog and social media content, and we're able to categorize it by sort of understanding what's in the photos. So we can sort of determine stuff about the influencers, like maybe what their gender is, what their age is, and what their ethnicity is to some level of accuracy. There's lots of excellent papers written on this. This is sort of an image from one of the papers where you can kind of get a rough idea about what we'd be doing. So we're taking an input image, we're sort of detecting faces in it, we're cropping them, aligning them, and then we're putting them through a model to sort of roughly predict an age. It actually works quite well, age prediction, machine learning. It tends to do better than people at estimating age. So the tools of the trade here, convolutional neural networks. We'll talk a little bit more about that, about what they are later, if you're not familiar with that. Transfer learning, we'll talk a lot more about that later. And then again, the face detection models and algorithms, which for us are sort of mostly just off-the-shelf products, but they're still extremely useful. And then we're doing a lot of stuff with natural language processing. So we're able to sort of infer a lot of stuff from what people say. We can kind of figure out what topics they might be interested in, roughly where they're from, what gender they are, maybe from the text, what profile type they are, whether they're sort of a human or a brand, whether they're like a fake bot account, and really a range of other stuff. So kind of an example of this is you might not be able to see that actually, but anyway, this is some textual input where we've got a biography of a person on Twitter who says, I'm a Toronto mum of 5, and sort of, we've got her name, we've got some of her post content, and from that we're sort of able to infer that, the gender, we're able to infer roughly the location, Toronto, whether they have children, and really a range of other attributes. So the tools of the trade here, a lot of sort of traditional ML. So we haven't talked about what deep learning is, but we will talk about that. But basically, logistic regression, SVMs, we've done a lot of this stuff. We've been doing this for a couple years. So we've been doing it sort of before the boom in deep learning. But we are starting to apply a lot of sort of deep learning to some of our NLP problems using recurrent neural networks, and specifically bidirectional LSTMs. Again, don't worry if you don't know what that is. We'll talk more about that later, but it's not that important. Pre-trained word embeddings, which is a way you can basically do deep learning with smaller data sets. Talk a lot more about that later. And then convolutional neural networks are again quite useful in NLP. And then lastly, not really machine learning per se here, but we're doing a lot of stuff with recommendation systems and search. So, roughly, if you're interested in this influencer, we think these are the other influencers that you might be interested in based on their content. The really effective sort of recommendation systems are all in the kind of collaborative filtering domain, which we'll talk more about later, and that's something we're sort of starting to experiment with. And then this is some sort of examples of NLP, of ML in use at Scrunch. So we've just we're able to tag. Again, you probably can't see this. That's a shame. My bad. Should have made it bigger. So we've got an influencer here, our CEO, and we're able to figure out that she's female. Roughly got her age range. Roughly got her ethnicity. We can kind of roughly figure out what the gender split is of the audience. So this is male, female, and then sort of brands and non-human entities. Roughly the age split, the ethnicity of the audience, and then we're able to do, this is sort of some more examples of kind of topic analysis where we're figuring out the topics that an influencer is mainly sort of talking about or mainly interested in, whether they're a person or a company, roughly where they're from, and just a ton more things in dev and actually in production in Scrunch. Cool. So part 3, this is kind of the core of the talk. There's kind of 7 topics that I want to cover. Each topic is going to kind of have require varying level of technical capability. So if you're finding one slide is sort of going over your head, then sort of stay tuned because the next one might be a little less technical. So we're going to talk about upskilling versus hiring. We're going to talk about how to start with no data, which is often the case for startups. We're going to talk about how you actually go about acquiring and building a data set. We're going to talk about what you can do when you have a little bit of data, how you can sort of make the most of it. And then, deep learning and modern machine learning techniques require sort of these things called GPUs, and they require a lot of compute. So we're going to talk about where you can kind of obtain those. We're going to talk about strategies for productionization and lastly, how to do research and how to kind of maintain your research. As I said, it's not going to be a particularly advanced talk as far as data science goes because I'm not a data scientist, so I wouldn't be able to do it anyway. But there is just sort of some basic terminology I'm just going to start using, so it's worth going over them. A model, it's basically this kind of black box that given some inputs will be able to return some output. It's usually trained by this thing called an optimization algorithm, which we're not going to talk too much about. Training data set, it's a data set used to train a model. So it's usually kind of these bits of data that have some sort of label that's fed into the model that trains it up. Validation set, it's the data set used to sort of validate the fit of your model while you're training. So that just kind of means how well it's doing while you're training, whether you're overfitting, underfitting, how well it's going to generalize. Test set, otherwise known as the holdout set, kind of used to evaluate the performance of your model after you finish training. Like this is going to tell you how well it's actually going to do when you send it to production. And the test set is going to come up over and over again in this talk. So it's worth just sort of remembering that. And then lastly, we'll finally sort of say what deep learning is. It's basically just a machine learning technique that's taken off in the last few years because it's really effective for certain problems, in particular image classification and speech recognition. Alrighty, so part 1 of this, we're going to talk about upskilling versus hiring, where to find ML talent or whether you can just learn it yourself. So firstly, upskilling, so learning it yourself or having other engineers in your company, maybe learning this stuff. I kind of believe that if you can learn to code, you can learn to be an ML practitioner. Jeremy Howard, who's this really awesome guy who has put together this course called Fast AI with his partner Rachel, says that people with 1 year of coding experience can become world-class deep learning practitioners. I think that's true. I think the thing to highlight here is the word kind of practitioner. Maybe you're not able to do this really advanced research and learn about new CNN architectures or whatever, but you can certainly take the research that's out there and put it into practice with just a little bit of skills. It's not particularly easy to learn all this stuff, but it doesn't really take much knowledge to be able to offer business value in certain domains. So I think that's worth keeping in mind. And I'm just going to give you a couple of places to learn online that I recommend, that I've used and that I really like. Fast AI, I think that's just absolutely one of the best online courses you'll ever find. It's leagues above any of the others. It's extremely practical, and there's lots of theory as well, but Jeremy has this really intuitive sense of how to explain theory in this way that's just really easy to understand. He does things like teach you about convolutional neural networks in Excel spreadsheets, and it's super cool. I know Brisbane.AI have had a few sessions where they've kind of gone over Fast AI as a group, which I thought was a really cool idea. Andrew Ng's course on the deep learning specialization, it's a really great course. Andrew Ng's obviously a really notable player in this space. The thing I'll say about it is it's very theory heavy, so it's worth sort of taking a look at. Once you've kind of got some practical skills under your belt, I would start with Fast AI and then go to that one. That said, the third course, Structuring Machine Learning Projects, is just a really, really practical course with some crazy, crazy good insights from all his years being the head of AI research at Baidu, which is like the Chinese Google. Kaggle, whoopsies. Let's unlock that. Cool. Kaggle is super useful. It's this kind of place for doing data science competitions. There's just there's a thing called kernels on there, which is like these notebooks that the community is sort of sharing with everybody. And I feel like every business problem has been sort of solved on Kaggle to some degree, and usually in a pretty amazing way. So it is absolute goldmine for solutions to real problems. The maths crops up a little bit here and there in deep learning, maybe not as much as people think, but there are some reoccurring themes. Linear algebra, multivariate calculus, probability crops up a lot. You can learn it all on Khan Academy. Khan Academy is absolutely one of the best platforms I've ever seen for online learning, and I really love it. The one book I'll recommend is Hands-on Machine Learning. The reason I recommend that is because it's the only book on machine learning that I've ever read, so it's the only one I can recommend. So if you're not able to learn it yourself, how do you go about hiring experts? This isn't exactly my area of expertise, but I've got a few tips to share with you. So we know computer science graduates now are able to do machine learning and AI electives, and they're learning about some really sort of practical stuff. And often they're quite hungry to solve real world problems, and sometimes they're willing to exchange their sort of cutting edge knowledge with your sort of, software development operations expertise. Outsourcing is another option. It seems like there's a lot of organizations that are willing to do the sort of, solve your deep learning and machine learning problems for you. My recommendation here is if you are going to outsource your research, you need to be across the project evaluation. So you need to know what test set they're using to figure out how well their models are performing and what evaluation metrics they're using. We'll talk a little bit more about that coming up. Alrighty, how do you start with no data? So, I think the first thing you need to keep in mind is that you really want to validate your idea if you're a startup. You really want to make sure that you have customers that actually want to pay for your idea. So, collecting data, setting up an ML pipeline. This is sort of expensive stuff. This takes time, and you want to make sure that it's going to be worth it. So, maybe setting up a landing page with some pricing and collecting emails is the way to start. This guy Suraj Ravel has this really awesome YouTube channel that I love, and he like 3 days ago he made a video called How to Start an AI Startup, which actually has a lot of crossover with this talk. I've been working on this talk for like 2 weeks, so I didn't steal any stuff from him, just so you know. But anyway, he talks about basically you want to focus on the problem, not the solution. So I think this is a really good quote. If you remove AI from the company but it still has a valuable product, you're probably on the right track. So I guess a lot of people get caught up with wanting to play with really cool technology and don't actually think about how it's going to solve a problem for a customer, which is what you're all about. And my tip here is just simply, if you're building a startup, you should read the Lean Startup. I've heard some people saying it's less relevant in the age of ML and AI, but I still think it's worth reading. And I feel like I read it kind of 2 years too late, so I hope you don't make the same mistake as me. If you're not going to set up ML, you can solve a lot of problems with heuristics, with handwritten rules. Basically, a good example of that would be spam filtering. You could just simply, block all emails that come from known spammer domains. And in my experience as a sysadmin, that actually gets you about 70% of the way there. And the cool thing is, all of these emails that you're blocking from these known spammers, you're starting to build up a training data set. That's actually really useful data, and that's kind of the basis of how companies go about building data sets. Another example from Scrunch is topic analysis. We didn't know about these things called word embeddings, and we didn't know about unsupervised learning, which is how often people approach this problem. So we just simply got together and built up this big table of hashtags and keywords to topics. Not perfect, a lot of times it gets it wrong, but often it's good enough, and it validates whether customers actually want it. Oftentimes when customers are like, this shit is not working well, that kind of means that they want it to work well, and that means you've actually sort of validated that people are interested in it. I will say, this is a quote from this guy Martin Zinkovich, who wrote this book called Best Practices for ML Engineering. You want to eventually choose machine learning over a complex heuristic, so these sort of heuristics can get out of control, and they can get really complex and really hard to manage. At that point, it's probably time to start figuring out machine learning. And then I guess just the last thing, again, this tip that kind of keeps cropping up is you want to find a way to test your accuracy of your handwritten rules if you're going to go about that. So one way to do it is using a test set. The simplest approach is just take 100 examples at random and put them in a spreadsheet and just see how accurate your model is. Third-party APIs, obviously a common choice. There's so many awesome ones out there. For image recognition, Cloud Vision API is great. There's IBM Watson for all sorts of problems. Kairos, AWS recognition. They're often really great. So the only issue with them is we found them to be quite expensive for big data workloads. And you can see here, this is a chart showing the costs of using some of these services compared to sort of hosting ourselves. And you can see it gets quite cost prohibitive at scale. And then the only side note to mention here is that just because these APIs are created by Google or IBM Watson, which was able to win Jeopardy a few years ago, it doesn't mean it's going to do well on your data set. Your data set might be kind of unique and different from the data set that they were trained on. But again, you can simply just test the accuracy by building up this sort of production-like test set, and that's going to tell you how well these third-party APIs are going to perform on your problems. And then lastly, the common approach is to just get these pre-trained models off the internet. There's so many of them. ModelDepot.ai has this awesome list. It's a hand-curated list of pre-trained models. It's really great. Again, you can't really expect production results because your input data is probably different to what the model was trained on. Transfer learning is very helpful here. We'll talk more about what that is coming up. Again, this tip that kind of keeps cropping up is you want to build a test set to evaluate your model performance using your production data. And that's going to tell you how well a pre-trained model is going to do on your unique problem. All right, bootstrapping data sets. So how do we go about acquiring and building up a data set if we have none? Firstly, there's so many publicly available data sets. Some of them have really permissive licenses. There's this GitHub project called Awesome Public Datasets that I'd recommend checking out. It's amazing. There's so many public datasets in the public domain. And we personally have had really crazy mileage out of Wikidata, which is basically a structured version of the Wikipedia dataset. Yeah, it's really awesome. You can classify data by hand. This is kind of the classic way to go about building up a data set. There are some great annotation tools out there. One of our engineers, Philip, has done an audit of all of the annotation tools out there, and there's a lot, let me tell you, and we're going to publish that in our blog. The team at Max Kelsen, they wrote a blog about building up this annotation tool in Slack called Flocker that I thought was really cool. Not sure if that's open source, but you can check out the details of that on their website. There's platforms like Cloudflower or Mechanical Turk that basically take your unlabeled data and have a bunch of people that'll kind of label it for you. They can be quite expensive, but I've heard they're good. We don't use them, but lots of people do. Other approaches is just like, can you ask your users to classify the data for you? Maybe there's some sort of incentive that you can offer. In our platform, we have influencers kind of come into the platform and they'll sort of, they'll correct their profile in the platform and add extra details about it. And it's useful for them because it means that more brands are going to be able to find them. And then we're able to use that as more training data. So my tip here is just like, it's not as hard as you think to build up a training data set. Just kind of get started. Start with an annotation tool and then see if you're going to need a platform like Cloudflower or Mechanical Turk. You can also purchase a data set. There's a data marketplace called Data Circle that I just learned about the other week. That sounds like a really kind of cool idea. And then you can also partner with other organizations who maybe have some data that they're willing to share in exchange for perhaps some of your expertise. And we've had some like incredible mileage out of this approach. So that's definitely a good idea. And then lastly, I guess there's obviously user data. In Andrew Ng's talk called Artificial Intelligence is the New Electricity, which I think is really good. He talks about this kind of virtuous circle of AI where you build a product and then you use that to get some users and the users kind of naturally start to build up data and then you use that to train ML models to make the product better and so on. I think this talk in general is really awesome and everyone should check it out. In particular, the second half where he talks about product management in the age of ML and AI. There's some really, really good ideas there that I don't think I've ever heard anybody talk about. So it's really great. General advice with data sets, just get started. Like pick out an approach and just get started and you'll start to figure out the best way to go about building your data set. And then transfer learning, which we're going to talk about soon. It can help you do a lot with just a little bit of data. So, how do you go about starting when you have a little bit of data? Again, transfer learning. So transfer learning lets you do deep learning with small data sets. And at a high level, what you're basically doing is taking a model trained for some other problem, hopefully a similar problem to yours, and you're going to repurpose it on your data set. Transfer learning in image classification. So this slide's going to be just a little bit more technical. I'll provide some technical tips here, so feel free to just zone out for a sec if you're not that technically inclined. But basically, transfer learning in image classification is about taking a model trained on this big kind of data set, usually for like weeks, and usually with really powerful sort of GPUs. And then you take it and you just retrain the kind of these last layers of the model on your problem. The general idea is that the earlier models sort of have learned more abstract features. They've learned kind of textures and shapes, and the later kind of layers start to learn more concrete things like dogs, cats, people, faces. So yeah, you can just sort of freeze these earlier layers and just train these kind of later layers. The general rule of thumb is the more data you have, the more layers that you can kind of retrain. And the approach that has worked really well for us is just you kind of like slowly unfreeze earlier layers until your validation accuracy stops improving. And that's when you know you've reached the limits of your data set. My tip here, this is quite a technical tip, but you really want to pre-compute your activations. It'll speed up your training time significantly. What I mean by that is basically you're going to throw out this part of the model, you're going to feed your input data into it, you're going to return some predictions from this part of the model, and then you're going to basically save those to disks. And that'll allow you to get rid of this part of the model when you're training, and you're just going to simply train this part of the model. Generally, it's way faster. It requires a lot less compute. If you didn't understand what I'm saying, just take a look, Google pre-computing activations, and there's heaps and heaps of resources on that. It's covered in all of the first lessons of fast AI. Transfer learning in NLP, there's these things called pre-trained word embeddings, and basically, a couple of examples: glove, word to vec. basically what they're doing is they are learning a kind of this vector for each word that sort of understands the features of each word, and it'll allow you to kind of capture relationships between words. So you can understand things like man is to woman as king is to queen. A side note on word embedding, something that people might find interesting. Some researchers have kind of recently found that the word embeddings trained on these massive corpuses of human text have kind of learned the biases in human text. So a researcher named Bola Bastic, he was horrified to find that he put into his word embedding, computer program is to man as woman is to, and it came back with homemaker. And he basically proposed a bunch of strategies for debiasing these embeddings. And you can find all those in Andrew Ng's deep learning specialization on RNNs. And he had a quote that I really like, which said that we have better strategies for reducing the bias in AI than in the human race, which I think is really true. A few more things, what to do with smaller data sets. This is just sort of standard kind of deep learning ML practices. Data augmentation, so if you've got an image data set, you want to take them and kind of flip them and skew them and rotate them and change the colors and all these sort of things you can do to start to build up a bigger data set. It's nowhere near as effective as just finding more data, but it can work if you can't find any more data. Regularization, things like dropout are really useful for small data sets, and these things called L1 and L2 regularization or weight decay that are also super useful. There's a blog here that I'd recommend by this guy Francois Chollet, who wrote this library called Keras, which is super cool, called Building Powerful Image Classification Models Using Very Little Data, and I would recommend you check that out if you have a small set of images that you'd like to classify. So my advice here, I think this is really key to ML problems. This is really it. This is the only advice that I'd recommend you remember if you remember nothing else. If you want to know why your model is performing well in your development, but not so much in production, it's probably because your test set does not match your production distribution. In other words, the thing that you're testing the model's performance on is different from the data you're feeding it when it goes into production. And this is a guideline from Andrew Ng, again, from this structuring machine learning projects, which I thought was really good, which is choose a dev and test set to reflect data you expect to get in the future and consider important to do well on. And I guess a lot of problems where people find that ML doesn't work that well in production for their domain is often a result of just not being able to find a good test set that's kind of reflective of the data that you're going to get in production. So domains like finance, trying to predict stock market data, it's often the case that the past results that you collect, the historic data, is very different from what's kind of coming up in the future, and therefore if your test set is made of historic data, then it's difficult to evaluate the performance of your model. Compute. Where do you get compute? You may have heard that you need GPUs and really powerful machines to do this thing called deep learning, and I'm just going to quickly go through some examples of that, of where you can find that. There's a product called AWS SageMaker, where they basically give you these things called Jupyter notebooks that are kind of pre-configured environments with all the things you need to be able to do deep learning. They're really cool. It's really useful. We've used it a little bit, and it works quite well. It can be quite expensive. If you're training all the time, it can be up to $1,000 for a month. There's a product called Floyd Hub, which is kind of a similar idea. I think it's even a bit better than AWS SageMaker. It's a bit cheaper. There's a product called Amazon EC2 instances can be used. They have these things called deep learning AMIs, which are just like pre-configured templates with all of the stuff you need to be able to do deep learning. It's often a lot cheaper with this thing called spot pricing. Yeah, I won't go into detail of what spot pricing is, but yeah, actually, I'll just skip that. Google it. It allows you to get servers at Amazon for a lot cheaper. Paperspace, another great alternative. It's recommended in the FastAI version 2. That's the first I've heard of it. I really like it. It's super cheap. I use it at home for all of my sort of training needs, and so that's kind of my personal recommendation. But all that said, it's hard to just beat building your own machine. And this is what we've done at Scrunch. We just found that the cloud solutions just got too expensive when you're needing to train models all the time, and you're often better off just building your own machine. This is an example. This is our machine at Scrunch that kind of sits under my desk. There's a blog article here called the Great $1,700 Deep Learning Box. I would recommend checking that out for some ideas for how to build a machine on the cheap. The con here is that it's more difficult to access remotely, compared to like cloud solutions. But there's tools like reverse SSH tunneling that will let you do that. All right, and just some quick advice. Just if you are doing deep learning on a GPU, just make sure you're making use of the GPU. If you're using TensorFlow, you need to install a certain TensorFlow library. Check your logs, figure out how to do it for the library that you're doing. Just make sure you're taking advantage of it. Alrighty, we're almost there. So productionization tips. How do you take the model that you've been training for all these weeks and get it into production? So the common approach to productionizing models is just to put your model behind something like a Flask API and just kind of host it somewhere. So you just use sort of standard microservices or HTTP, just the regular stuff that you might be using already in production to serve your models. We really like AWS Lambda for serving models, and we've written a blog post on it that you can check out. We had to do a little bit of sort of finagling to get it to work in Lambda. But I guess the cool thing about it is it means we've got these sort of all these isolated models that can have whatever dependencies they need. And it's allowing us to sort of build up this catalog of models that we can use across the business. So when we come up with a different product idea, we can just simply reuse all these models that we've trained for other ideas. Just a quick discussion on data pipelines. So they're usually just these systems for ingesting and processing data. So taking data in, maybe classifying it with your models, and then spitting it out to the user somehow. We use this queue-based pipeline that I've kind of got a diagram of here. It means we can cope with burst workloads, so we can have a bunch of people suddenly wanting to use the platform. Maybe we got on the front page of Hacker News or something. And it's also a way to not to lose data. I like this quote from Martin Zinkovich, who says that keep the first model simple and get the infrastructure right. Oftentimes, the infrastructure, building up the data pipeline, is where you're going to spend a lot of your engineering investment. So it's worth getting that right. Two ways of kind of going about serving models to your customers. One of them is live predictions. So maybe your customers will upload an image and you'll tell them whether it's a dog or a cat. The cached is where you kind of make all these predictions on your data in the back end and then save them in some sort of database so they can be queried by the users. This is the approach we take. We sort of cache all our predictions and store them in Elasticsearch. So when our users are querying Scrunch, they are querying cached predictions. My tip here is you want to store some description of the model and an encoding of the input data used to generate the predictions, like say an MD5 sum of an image or the text, alongside the input data, or alongside the predictions rather, and that'll allow you to prevent unnecessarily reprocessing your data. And then lastly, just talking about monitoring, standard stuff with monitoring any kind of HTTP API. You want to figure out the performance, the latency, how well it's doing, whether it's up, whether it's down, all these kind of things. But also in ML, you need to have a way to evaluate your accuracy of the model ongoing. You need to figure out, is it still performing as well as it did when I first shipped it? Oftentimes there's a human component involved in this where you'll kind of like take hundreds of predictions at random from production every week and evaluate them just by hand. That's just the common approach. Some models, they have a tendency to kind of go out of date and they need to be retrained on an ongoing basis, particularly NLP models, because kind of people change the way they speak over time. So you need to think about how you're going to retrain it, whether it's going to need to be retrained daily, weekly, monthly, yearly. All of these sort of things need to be considered. All right, this is the last section in part 3. I'm just going to talk about research. Only 2 slides in this. The first is, I guess, at some point, if you're going to be playing with sort of cutting edge stuff, you're going to get your information out of academic papers. There's usually a lot of theory and a lot of maths in the academic papers that maybe you don't need to understand in order to sort of utilize the solution that they're describing. There's often an open source implementation that you can use for reference. And there's a lot more about how to read kind of academic papers in the FastAI Part 2, Lesson 1, which I would really advise everybody check out. But basically, Jeremy Howard says that a good approach to take is like get started by reading papers for problems you sort of already understand. So maybe you could watch a few YouTube videos and figure out how to sort of solve some problem or figure out some model or something, and then try and read the paper that kind of describes that. And then in terms of sort of managing the research that you do as a company, I think you want to be really meticulous with your research. You often come back to your research maybe after a few months, maybe after a few years, and you want to try and improve upon it. And if you haven't stored your results kind of meticulously and thought about, archiving your models and archiving all your checkpoints, you're going to be in for a bit of trouble. The approach we take is just store our research in version control alongside all of our code. I think that works really well, and then you can go back kind of historically and see what happened with your research, maybe see where a model might have gone wrong with training. A lot of startups who are doing this sort of work are going to be claiming the R&D tax incentives, and the audits can be extremely time-consuming and painful if you aren't meticulous with your records. So just trust me on that, I know from experience. And I guess if you are claiming R&D tax incentives, you want to be ensuring that your kind of research is following the scientific process. So you want to be thinking about what is your hypothesis, what is the knowledge that you're generating. You want to think about why it's novel. Maybe it doesn't have to be some sort of like brand new reinforcement learning technique that no one's ever thought of before. But you could be sort of taking existing research and applying it to your business domain. And maybe no one's done that before, so that's why it's novel. And then you want to also think about your results and whether you kind of proved or didn't prove the hypothesis. So let's just recap on all that. I know there was a lot of information to take in. I'll post up the slides online. There's a fair bit of, I think, valuable information on this, so it might be worth reviewing them after the sort of talk finishes. I'll just recap again. Number one, you can upskill it internally. People can learn ML. They're not some sort of, people who are doing ML now, they aren't like geniuses, otherworldly geniuses. They're just people. It's worth trying to validate your product without ML. See if your customers are willing to pay for it before you go down the path of collecting data sets and building up your ML sort of training environment. Lots of ways to go about bootstrapping data sets. Just start with one idea. Your strategy will evolve over time. Transfer learning is an awesome way to take advantage of smaller data sets. I recommend you checking that out. Lots of compute options in the cloud, lots of ways to get GPUs for reasonable prices, but it's pretty hard to just beat building your own machine. You want to consider your production strategy when you are going to launch your model. You want to think about your pipeline, your live versus cache predictions, your monitoring plan, and your ongoing retraining plan. And then lastly, you want to store your research in version control and be meticulous with it. And we'll just quickly look at an example of Scrunch, of a product that we kind of shipped recently and how we sort of followed this process. So we had customers that wanted audience analysis for influencers. They didn't just want to understand attributes about the influencer. They wanted to know attributes about the influencer's audience. And we have competitors that are doing this. So we knew it was an important problem to solve. But basically to validate it, we found a customer who was willing to pay for like a single analysis for a single influencer. And they were going to pay a certain amount for each one. So already we've kind of got somebody who's willing to pay for it. So it means probably a good idea for us to work on it. The first version, we did it without ML, so we used a third-party data, and we sent all of the sort of audience data that we've collected to this third-party API, which was able to return us predictions about gender and age and a bunch of other things that our customers requested. And then we could use this to sort of bootstrap our training data set. And then we went about collecting other publicly available data sets and just like collecting data by hand. Required some hand cleaning, but eventually we had a reasonably sized data set. We looked around for some good academic problems that were solving, had solved similar problems to the ones we wanted to solve. There's some great ones about, gender inference and age inference and ethnicity inference. And the cool thing is, I guess they have sort of the accuracy that they've been able to obtain in their training, and that'll give you a good indication of the sort of accuracy that you should expect and sort of some sort of goal for what to work towards. And then also, if you've used a third-party API, well, you can simply verify your model's performance against the third-party API to see how well it performs. And then lastly, we were able to deploy it and ship it into our pre-existing pipeline. We then built this kind of API that was very similar to the vendor's API we were using, so it was just very easy for us to sort of replace their API with our model. And that worked really well, and that's currently in production now. Cool, so that's section 3 finished. The last part, we're just going to talk about what's next for machine learning at Scrunch. So just some of the things that we're kind of working on next and why. So we're looking into face verification and recognition. Basically, one of the tools that we provide is we kind of join people across networks. So we might have someone on Twitter, and we want to sort of match that with their Instagram profile, or maybe with their blog, or their Facebook, or their YouTube. And we kind of do that now with handwritten rules. But there's this thing that's kind of come out in the last I think it came out in 2016, called a sort of a Siamese network. Basically the idea is it learns sort of this encoding of some input, and it can be used to sort of figure out the distance between some other input. So kind of concretely what that means is you'll be able to get some face, get some sort of encoding of it, get another face, get an encoding of that, and that encoding will be able to tell you whether it's likely that it's the same person. And we think that's going to be useful to take that kind of person joining to the next level. Object detection, we want to do some analysis of what's actually in the image, so not just understanding what the people are in the image, but also like what else is in the image. And we kind of think that's going to give us like a much deeper level of sort of understanding of consumer and influencer preferences. The algorithms, YOLO it's called, I think it's you only look once, and YOLO 2 have kind of come out recently, and the sort of impetus for that has been self-driving cars, but we think we'll be able to take advantage of that in influencer marketing. There's a lot more about this in the deep learning specialization part on CNNs in week 3. It covers this stuff in depth and how these all work, so I'd recommend checking that out if you're interested in it. And then lastly, we plan to build a much better kind of collaborative filtering recommendation system. So collaborative filtering is about taking some user A, figuring out what their preferences are, and then finding the user whose preferences are the most similar to that. So person B might have very similar preferences. We look at what else person B likes that maybe person A hasn't seen yet, and use that to recommend stuff to person A. So that's often, that's how Amazon works, that's how kind of Netflix works. It's generally the best way to build recommendation systems. And we're hoping that it'll give us some tools that'll allow us just to find the perfect influencer for a campaign by having a brand just type like the first kind of parts of their brief, of their campaign brief. And there's much more planned. And that's it. So thank you so much for listening. We're hiring, so we're looking for full stack developers and ML engineers. If you're interested, dev@scrunch.com. Thank you. We are using version control. So all of our code is in version control, and I guess I come at it from the perspective of a software developer. So version control is really, really important for keeping track of code. It's essential. I think if you're not using version control to keep track of your code, then you really should. And basically, our research is now just living alongside of our code. So all of the sort of management of our code, it's really the same thing for our research. And I guess the beauty of it is you can kind of just go back into any point in time and say, okay, well, what happened, 2 months ago, and what happened 3 months ago, and if something's going wrong, like when did it go wrong? And that's kind of the beauty of version control. That's sort of why you want to use it.
Just a question for me, Lex. I was wondering, how long did it take you to build your own machine? I thought that was really inspiring. So give some more thoughts on that.
I don't know. It was actually built before my time. So the ex-CTO before me put that together. So yeah, I'm not sure. Sorry. Yeah.
So you said it's very important to test data, so good test data.
Yep.
But at this point at Scrunch, there's
Yeah, I would say in general, more data is the best way to get more performance out of your models. Like especially with deep learning, it seems like with deep learning, it just has this like infinite sort of appetite for data, and it's like the more data you collect, the better your models are going to perform. I think all of the models out there that now, like all of the kind of modern sort of models for sort of image classification, they're all pretty damn good, and it's just like if you can feed it more data, they'll perform better. So yeah, definitely the more data, the better, I would say.
Any other questions?
And have you got any models, or those existing models that you can use for items that don't happen often? For example, a financial crisis might happen once every 8 years, or a terrorist attack might happen once every 20.
Yeah, no, we're not doing any, that sounds pretty crazy. That's probably a bit too much for us now. We're not doing sort of any forecasting or anything like that. It's mainly about just like taking some textual data that we've got now and figuring out, you know, what are some attributes about it. But that stuff's certainly cool. It's not really my area of expertise, so that forecasting stuff. I'd love to learn about it, but yeah, I haven't come across it. Yeah.
Hi. Do you use, what are your thoughts on using various frameworks like TensorFlow versus building your own?
Yeah, I probably wouldn't build my own. I think the first exposure I've ever had to like trying to build these sort of deep learning tools from scratch was in the in this Andrew Ng's deep learning specialization, and it's really hard. It's super hard to do. There's like a lot of complexity comes into it, and that's where you really need to have a good intuitive sense of all the maths. So I would definitely recommend using some of the tools. TensorFlow, Keras are kind of our favorites. I've heard PyTorch is really great. It's going to take you a long time to sort of get started if you're trying to build all these tools yourself. So you want to piggyback off, you know, all the work that's already been done.
You gave some recommendations or some advice about what to do with stored data or simple data. How do you balance that up with later learning as the model works out exactly the answer that you put to it?
Yeah, so I guess it can't be that small a data set. It needs to be a reasonable size. But this is where having a good validation set comes into play. So this will kind of tell you whether you're starting to overfit or when you're starting to underfit. And it'll also, oftentimes you'll find that the solution is just throw some more data at it. So again, yeah, good validation, good test set. That will tell you kind of what you need, how much more training data you might need to acquire.
One more. Hi, I want to ask, how well does transfer learning improve on the original model? Like, what is the biggest progress you've ever made image recognition-wise?
I guess, so if you just think about like the reason for doing transfer learning, you know, I guess it's usually like the models that you might get, like the common kind of models that you get have been trained on this thing called ImageNet, and they've usually got like thousands of different categories that they're trying to predict. And so oftentimes you don't need 1,000 categories, you just need maybe 2 or 3. Like in our example, we might just want to know whether it's sort of male, female, or a non-human. So I guess the general reason for it is like taking all of that knowledge and applying it to your particular problem. It's not usually about trying to kind of improve upon their work. If that makes sense? Cool.
So I know how I'm very super impressed myself. So I think we'll all agree there's a lot of excellent insight in there tonight. So I want to say thank you, Lex.
Cool, thank you.